We're talking about complex numbers. Complex sounds like complicated, right? These numbers are complicated because they involve negatives underneath the square root. Remember when that happened, whenever it was negative underneath the square root? Then we just say, oh, there's no real answers, which implies there's answers that are not real, right? It does. There are answers that are not real. There are answers that are imaginary, and that's what we're going to be dealing with today. All right. I am going to go to this one and ask you to grab your graphing calculator and graph this puppy. There's no reason you have to do this by hand. This will be a lot cleaner and nicer to look at if you have it on the graphing calculator. All right. Once you have graphed it, I want you to remember, where are the answers? The x-intercepts. All right, well, what are the x-intercepts? There aren't any x-intercepts, are there? Would you use your MAD calculator skills and figure out the minimum for this thing? That will also be known as the what, starts with a V, the vertex. What is the vertex? I know it's a decimal, and that's okay. Round it for me. It's about what point what, comma, what point what. Who's got it? Yes, sir? Negative 1.5? That's just a number. I need two. Negative 1, comma 5? Negative 1, comma 5? It's actually a whole number? Awesome. Okay, if the vertex really is negative 1, comma 5, here's a good little review for you then. Write for me the equation of this in vertex form. Y equals something squared, you know? It looks kind of like that. It's really easy. Write me the equation for this thing in vertex form, since we just told you what the vertex was. The equation for your parabola, write it on your paper or your virtual paper in vertex form. Were you smart enough to know that you needed to change that -1 to a +1? Raise your hand if you remembered that. Awesome. Comma, and then there's a plus, and there's no comma, sorry. +5, there we go. Remember that? That's vertex form. Okay. Now, general form versus vertex form. If I wanted to use my calculator, well, wait a minute, one more thing. I know something else from this vertex form, or no, general form. That's 6 telling me something. What's it telling me? Y-intercept. Y-intercept 6. So if it goes through this spot and that one's the vertex, it's really easy to know that it kind of goes like this. Okay, good. Now, tell me, if the roots are the x-intercepts and there are no x-intercepts, does that mean there are no answers to this thing? No. There has to be answers. In fact, specifically, because it's got a 2 here, there has to be 2 answers. So how could there be 2 answers if I don't see any answers? It's because those answers are imaginary. The answers are imaginary. Now, how can I figure out what they are if they're imaginary? That seems ridiculous. Kind of like, draw me a picture of that leprechaun that you can't see. Well, actually, you don't actually need to draw the picture of the leprechaun. What I'm trying to say is, how are you supposed to know where these things are? They aren't a place on the graph anymore then. They are an answer you can get from the other thing that I told you would always work to solve quadratics, even when it doesn't touch like this. It can still solve them. What's that powerful, powerful thing? The quadratic formula, or the quadratic equation. I hear it called both, and either is okay with me. So then, would you please take a moment, and this is something your calculator cannot do unless you've got a Neo program called Quad, which is pretty awesome, but I've got a x equals negative b in my head, -2, plus or minus the square root. Write this whole thing out, and then I'll tell you how to find the answers that are imaginary. Mm-hmm. I saw that. Be good or you'll have a new seat where I can see everything on your iPad. All right. In the front row, tell me what to do in this empty spots by the 4 there. Yes, because it's A and C, which are 1 and 6. Excellent. Now, do you see why it's negative underneath the root? Because we're going to have to do 4 minus 6 times 4, which is 4 minus 24, which means negative 20, right? But in the old days, we would just say, oh, you can stop there then, because you know the answer is not real. But now we want you to actually figure out what the answer is. So it's negative 2 plus or minus the square root of negative 20 all over 2. And it's not like we're just going to say, oh, I know the square root of negative 20. It's 6.39. We don't do that. We have the answer that has an I in it. Do you remember knowing? Have you ever been taught I? I mentioned it before. Okay. Well, let's be specific on how it works. This is a right answer so far, but we can go further if you know what I is. I was invented by this guy, Leonard Euler, and it's a way to solve imaginary number problems and get an answer even though the answer is imaginary. So this guy solved these problems in the late 1700s. That's a long stinking time ago. Okay, was the United States, well, when did the United States Declaration of Independence get signed? Do you remember that? 1776, okay, so in the late 1700s, that's in the same neighborhood. Right about when we were signing the Declaration of Independence, this guy was eating some pasta and figuring out that the square root of negative 1 was possible if we used a number for it, or a letter for it, and we called it I. Okay, so how does that work? If I have the square root of 25, you know that answer. What's that? 5. What if I make it negative 25? It's 5i. Very good. It's not quite as simple as saying, oh, it's 5, but it's imaginary. It's not quite that simple. It's 5i, but it's because of this. Remember when I had square root of, let's say, 60? I could break that into root 6 and root 10. You can break anything into square roots if you want to. Like square root of 24. And the square root of 24 would be square root of 4 and a square root of 6. And that part's real, so 2 root 6. Sorry, that part's rational. By the way, what's this part? If this part's rational, what's this part called? Irrational. Good. And we're going to add a third kind. There's rational, irrational, and now what? Imaginary. Okay. And imaginary comes in when we do this. Square root of 25, that breaks down into root 25, which is going to be 5, and root negative 1. That's why the root negative 1 thing is important. The square root of negative 1 is I. It's a definition thing. So now, if this equals this, and this equals 5, and this equals I, that's how the answer is 5i. All right, so let's give you another one like that. Square root of 16, but make it negative. I know, the answer is 4i. All right? But why? Because it's the square root of 16 times the square root of what? Negative 1, and that's equal to I, and that's equal to 4. That's why it's 4i. All right, see if you can handle this one. Square root of negative 24. Break it into 3 square roots, one of which will be negative 1. Now turn it my way so I can see what you think the answer is. Close. Did something wrong with your number at the very beginning. Good. Good, except that I'm seeing a lot of people do that. Okay, a lot of people got this part, which is cool. Root 6, root 4, and root negative 1. And a lot of people knew that that part was 2, and this part was what? I. And then there's the square root of 6. But there's a right order to put it in, and here's the right order. The 2 first, the real part first. Next is the imaginary part, and the last is the irrational part. 2i root 6. Did anybody psychically know exactly what order to put it in? Several of you did. Nice work. Okay. All right. By the way, if you're ever adding 2 numbers, Which do you think comes first, the real part or the imaginary part? The real part. So if you have 5 plus 3i, I've written it correctly. Now, I get it marked wrong. Because this is what's called a complex number. Because it's got both real parts and imaginary parts. And if you've got both kinds, you're supposed to list the real parts first. So that part comes first. Just like I think you guys know this. If I wrote this, technically I wrote it wrong. There's an order you're supposed to write things in. The one with the biggest degree is supposed to be first. Okay, so same idea. There's a right way and right order to do it if you got complex numbers. The real part is supposed to be first. All right, now we're getting really close to being able to go back here to the first problem we did and actually get the answer. You remember how we got stopped right here because we had the negative running to the square root and we would have normally just said, oh, no answers. Now you can keep going. Would you please take the square root of negative 20, break it down into its parts, and then see if you can cancel some stuff, which you will, and then you'll have the final answer. Okay, first step, did you see that root 20 broke into root 4 and root 5 and root negative 1? So that's 2i root 5. All right, so what do I do now? X equals negative 2 plus or minus 2i root 5 all over 2. Do you notice that this and this and this all have a 2 in them? Let me tell everybody write down what you think the final answer is and zoom in on it so that I can see it. And I'll check it off for you, yes or no. You're close, but it can be simplified further. They don't all have an I. They all have a 2. So if they all have a 2, cancel the 2 off. Tell me what you get. Yes, 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 yup, 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 good, yes, yup, good. I think I already got yours. Yes, yes, yes. Everybody's getting it right. Okay, good. All right. I think you're getting this. Y'all got negative 1 plus or minus I root 5. Do you know why a lot of kids think this number in the front is just gone? What do you think they're doing wrong? Probably not subtracting it. They're knowing there's a 2 in everything, but then they think what? Yes? And I get exactly what you're saying because the plus and the minus here, if I threw an extra minus here, it wouldn't really matter. But if the 2 just disappears, it's not because they thought it added and subtracted away, I don't think. What do you think is, yes, Miss R. When you're canceling it out, and people go like this, cancel, 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 and they think what? Yeah. When you cancel it, they think it just like disappears, like that 2's gone. But it actually really, 2 goes into 2 once, 2 goes into 2 once, 2 goes into 2 once. That's what you're really doing. Okay, good. All right, I think you're getting it. And I think that means we can just get to your homework. Let's not waste any more time. So grab your homework. You'll find it. And there's one more thing. I like doing something called pre-teaching. And that's like teaching you something ahead of time before we really have it. That way, when we do it, it'll feel easy. I'm going to do a little pre-teaching of tomorrow and tell you one more thing that you can do with eyes. It's also kind of cool because it's on the ACT test, and anybody that would want to take the ACT test, it is coming on this Saturday. This Saturday, a lot of juniors are taking it. You don't have to take it till you're a junior, but to be honest, a lot of you guys are ready for it. You wouldn't have to wait. The ACT is only going to have 4 questions on it you wouldn't know, and they are all heavy-duty trig questions that you'll learn next year in pre-calc. Yes, sir. You can take it you can take it. In fact, there's one guy who took it 18 times. Literally. Took the ACT 18 times. He raised his score quite a bit. I know one guy who started out at a 31, which is a really good score, and he took it like 5 times and got it up to a perfect 36. That was kind of impressive. He get to 36. You like get your name in the paper. It's that hard to do. So, but yeah, you can keep taking it over and over again if you want to. The only thing I would recommend is don't send it anywhere, because if you take it as young as you are and the score isn't that good, you don't want to mail it off to the college before, like you think you want to go to the U or whatever. Don't send it to them yet. Wait. Because here's the thing. You only send the scores out that you want to send. You could take it and get a 1 and just never show anybody, and nobody will ever know. Like, colleges don't get told what your score is unless you tell them by sending it to them. So don't send it to any colleges until you're confident you got a good score. But there's nothing wrong with taking it for practice. That's not a bad idea. All right, so anyway, back to what am I going to pre-teach you? I want 30 more seconds of your time. So everybody stop, shut your iPads, and just see if people can absorb this. If I squared, shut the iPad, still waiting for a few people. If I squared means I times I, wouldn't you agree that I times I means the square root of -1 times the square root of -1? Do you agree with that? Do you know what happens when you take any two square roots and you multiply them together? Let me give you an example. Square root of 7 times square root of 7. That's the square root of 49, which is 7. And square root of 8 times the square root of 8 is the square root of 64, which is, you get the pattern here? So what's I squared equal to? Close. -1. It's what's underneath the root, right? See? What's underneath the root? -1. So what's I squared equal to? -1. So here's a typical ACT question. They test you to see if you can figure that out and use it when the problem looks like this. What's 6i plus 4i squared? And then they add another 2. And they ask you to simplify it. It's really easy if you know what I squared is. What's I squared? So, figure it out. What's the answer? 6i. Can't simplify that, right? Because that's not an I squared. So, what's that part right there? So, 6i minus 2. Because this part would be worth what? -4. Because it's 4 times -1. -4. -4 plus 2 makes -2. There's the final answer. Wherever you see I squared, you just put -1. That's what the main part of the lesson for tomorrow is. All right, that's all I got for you for today.